Good evening, everyone. In the last session, we discussed about Kubernetes architecture and Kubernetes cluster setup with multi-node. Here, Kubernetes cluster we can set up in two ways. One is self-managed Kubernetes cluster, and the second one is provider-managed Kubernetes cluster. Self-managed cluster means we have to set up our own cluster. Provider managed cluster means AWS, GCP, Azure. The cloud providers will provide a cluster to run our application. First, we are going with self-managed cluster. Self-managed cluster we can set up in two ways. One is by using Minikube. Second one is by using Kubedium. Minikube is a single node cluster just to learn the concepts of the Kubernetes, but we don't use that for real projects. For the real projects, we are going to use multi-node cluster. To set up the multi-node cluster on our own, we are going to use Kubedium. If you don't want to go for self-managed cluster, then you can go for provider-managed cluster. AWS providing EKS service to set up Kubernetes cluster. Azure Cloud providing AKS, GCP providing GKE, IBM Cloud providing IKE. Like that, there are provider-managed clusters also. Fine. So, and we started our discussion related to Kubernetes core components. So Kubernetes, we can call them as Kubernetes resources or Kubernetes objects, or we can call them as Kubernetes workloads. First thing is container, pod, then namespaces, service, deployment, replication controller, replication set, daemon sets, persistent volumes, stateful sets, role, secret config maps. These all are the core concepts of Kubernetes cluster. Okay. Now first, container. We know that already container is a runtime process of our application. Whatever the application that we want to execute, we will package that application as an image. That image we are going to execute. So image runtime is called as container. So we are creating Docker containers here. Docker containers we are going to use to run our application. To run the Docker containers in a machine, we need a Docker engine. Docker engine is called as runtime for the Kubernetes cluster. Okay, so Kubernetes is not replacement for the Docker, guys. Docker containers we are going to execute by using Kubernetes. Docker is a containerization platform. Kubernetes is orchestration platform. Orchestration nothing but managing the processes, managing the containers, scheduling, deploying, and managing the containers will be taken care by Kubernetes. That's why it is called as orchestration platform. Kubernetes is used to manage our Docker containers, and here Kubernetes will not manage the containers directly. Kubernetes will use a concept called pod concept. Pod nothing but a smallest building block which we can deploy in Kubernetes cluster. If you want to deploy any application by using Kubernetes cluster, for that we need to use a pod concept. Pod is a smallest unit building block that we can execute in the Kubernetes cluster. So here multiple containers will be wrapped into one unit that is called as pod. Containers will be grouped logically. The logical grouped containers will be called as a pod. Okay, guys. Now we can use a pod with a single container. We can use a pod with the multi containers also. Within the pod, we can run one container or we can run multiple containers also. Good. So before going to understand the pods concept, we discussed about namespaces. Namespaces nothing but a cluster inside another cluster. Namespace nothing but grouping Kubernetes resources. Grouping Kubernetes resources. A cluster inside another cluster. We can achieve a cluster inside another cluster by using namespace concept, right? Kubernetes components. What are the components? Like whatever we discussed here, pods, namespaces, services, deployments, replication controller, replication set, all these things we can group together as one namespace. So namespace is similar to packages in our programming languages. So it is just logically we are going to group them. We can have multiple namespaces. We can have multiple namespaces. So by default, Kubernetes is providing some namespaces for us, like a default namespace, kube system namespace, kube public namespaces like that. We can create our own namespaces also by using kubectl create namespace. Okay, for one application, we can have multiple namespaces also. As we discussed yesterday, SBI application having a customer application, SBI having a customer application, agent application, report application. For three different applications, three namespaces will be available. Logically, we are differentiating them. Okay, now whatever the pods we are running, every pod should be executed inside a namespace. Every pod should be executed inside a namespace. So we can create our own namespaces. We can execute the pods in our own namespace. If you don't specify any namespace, then pods will be executed by default in the default namespace. If you delete a namespace, then all the objects or resources which are associated to that namespace also will be deleted. Got it? So this is what we discussed in our previous session. Quickly, we revised it. So with this, are you comfortable with namespace concept? Are you guys comfortable with the namespace concept in the Kubernetes? Kubernetes set we have done as of now, we understood what is containerization, what is containerization, what is orchestration, what is Kubernetes, what is Kubernetes, Kubernetes advantages, Docker Swarm versus Kubernetes, Docker Swarm versus Kubernetes, Kubernetes architecture, Kubernetes architecture we discussed, architecture components, Kubernetes multi-node cluster setup, Kubernetes namespaces. This is what we learned so far in our syllabus. Are you guys comfortable with all these topics? What is containerization? What is orchestration? What is Kubernetes? What are the advantages of the Kubernetes? Docker Swarm versus Kubernetes, Kubernetes architecture, Kubernetes multi-node cluster setup, Kubernetes namespaces. Are you guys comfortable? Good, fine. Now let's start our discussion related to pods. Let's start our discussion related to pods. What is pod in the Kubernetes? What is a pod in the Kubernetes? A pod always runs on a node. Pod is the smallest building block which we can schedule to execute in the Kubernetes cluster. Pod is a smallest building block. So if you take any application, if you let me go to that Kubernetes PPT, so we have seen the architecture of the Kubernetes, right? So if you go to Kubernetes architecture, we have a master node and we have a worker node. We have a master node and we have a worker node. So when you see the worker node, pods are available. In the worker node, we can have multiple pods also. Pod is going to execute our containers. Kubernetes is the orchestration platform which is used to manage the containers. But Kubernetes is not going to manage the containers directly. Kubernetes will manage the containers by using a pod concept. Okay, what is a pod? Pod is the smallest building block that we can execute inside Kubernetes cluster. That we can execute inside Kubernetes cluster. A pod can have one container or more than one container. Pod can have one container and more than one container. Single container pod, multi-container pod also we can take. Single container pod and multi-container pod also we can take. Are you guys clear with this? In the Kubernetes cluster, pod represents running process. So whatever the application we are executing, right? In the Docker, container is a running process, but in the Kubernetes, pod is a running process. When you go for the Docker, in the Docker, image will be available. When you run the image, container will execute. Container is a running process in the Docker, but when it comes to the Kubernetes, pod is a running process. So when I say that my application is executing in the Kubernetes, that means your application is executing in a container, that container is executing inside the pod. Pod is the smallest building block that we can execute in the Kubernetes cluster. In the Docker, container is a running process, whereas in the Kubernetes, pod is a running process. Are you guys clear with my point? Are you guys clear with my point? What is a pod? Containers inside the pod, containers inside the pod will share a unique network, storage, and other specifications. So containers are running inside a pod, will share a unique network IP, will share the storage, and will share other specifications of that pod. So if you are running multiple containers inside a pod, all those containers will have a single IP. Good. Right now, so with this, we understood what is a pod. Pod is a small building block that we can execute on the cluster. Our container should execute inside a pod. A pod can have one container, or it can have more than one container also. Single container pod, multi-container pod. In the Docker, container is a running process. In the Kubernetes, pod is a running process. Containers inside the pod will share unique network IP, storage, and other specifications. That's fine. Now, I have a Docker image, guys. So let us go to our Docker Hub. Let me go to my Docker Hub. If you go to Docker Hub, I have some images in my account. Java web app, one image available. Spring Boot REST API, one image available. Now I want to run this Java web application. Docker image is available. I want to run this Java web application on the Kubernetes cluster. Can we directly run a image? Can we directly run a image in the Docker? If I have a image, can I directly run this image as a container in the Docker? Come on, guys. Can we run the image directly in the Docker? Image can we run in the Docker? Image, I'm not talking about the Docker. If I give you this image, can you run this image by using Docker? Yes, you can pull the image and you can run the image directly in the Docker. But when it comes to the Kubernetes, can we run the image directly in the Kubernetes? Can we run the image in the Kubernetes directly? No. So what you need to do to run a image in the Kubernetes? What we need to do to run a image in the Kubernetes? Come on, guys. If you want to run your application in the Docker, image is sufficient. If you have a image, you can run the image. When you run the image, container will create. Container is a runtime process in the Docker. But in the Kubernetes, Kubernetes will manage the containers directly, or Kubernetes will not manage the containers directly. Kubernetes will not manage the containers directly. Kubernetes needs what? A pod. So if you have an image, with that image, you need to create the pod. Then Kubernetes will execute that pod. Okay. So if you want to run our application in the Kubernetes, we need to create a pod for our application. To run our application, to run our image, we need to create a pod. Then Kubernetes will execute that pod. To run our image, to run our Docker image, we need to create a pod. Then Kubernetes will execute that pod. Kubernetes will manage the containers, but not directly. Kubernetes will manage the containers using a pod. So you need to create a pod. Then you can ask the Kubernetes to execute the pod. If we have pod, then we can ask the Kubernetes, we can tell the Kubernetes to schedule that pod execution. If we have pod, then we can send a request to Kubernetes to schedule that pod execution. Are you guys able to understand? Pod is the smallest building block. Guys, this terminology is very important. Pod is the smallest building block that we can execute inside the Kubernetes cluster. Inside the cluster, we can run multiple pods. Inside a node, we can run multiple pods. Pods will execute in the nodes. Pods is the smallest building block that we can execute inside the Kubernetes cluster. Pod will execute in a node. Pod will execute in a node. One node can execute multiple pods. One node can execute multiple pods. A pod can contain multiple containers. You see the diagram. Inside one node, multiple pods available. Inside one pod, multiple containers are available. That is possible. Pod represents running process. Containers inside the pod will share the network, will share the storage, will share the specifications and all. Now, how to run our application in Kubernetes? How to run our application in Kubernetes? To run our application in the Kubernetes, we need to create a pod. To run our Docker image, we need to create a pod. Then Kubernetes will execute that pod in a node. Right. If we have pod, then we can send the request to Kubernetes to schedule that pod execution. How to create the pod? How to create a pod? Come on, guys. We can create the pod in two ways. We can create pod in two ways. This is very important. Understand. We can create the pod in two ways. One is interactive approach. Second one is declarative approach. How many ways are there to create the pods in the Kubernetes, guys? How many ways are there to create pod in the Kubernetes? Two ways are there. What are those two ways? What are those two ways? One is interactive approach. Second one is declarative approach. Okay, interactive approach, declarative approach. Interactive approach means using commands. Using commands, we can create a pod. Using commands, we can create a pod. Example, using kubectl run my application name. I am going to give Java web app pod. Java web app pod. Take the image. My image is available. Ashok IT Java web app. Okay. So like this, we are going to give a command. If you execute this command, then for the Docker image, this is my Docker image. For this Docker image, one pod will be created. Kubernetes is going to execute that pod. How to execute the commands in the Kubernetes cluster? kubectl. Now we can execute the kubectl commands and we can give the image name. Then it is going to create a pod. Then that pod is going to schedule by the scheduler. Then Kubernetes cluster is going to execute that pod on the node. So this is one approach to create a pod. So why we need to create a pod? If you want to run your application, pod is mandatory. Kubernetes is not going to manage the containers directly. If you want to run a container, for that container you need to create a pod. That pod you need to execute. Then only your container is going to execute. How to create that pod in the Kubernetes? We can create pod in two ways. One is by using interactive approach. Second one is by using declarative approach. When we go for interactive approach, we have a kubectl command. We have kubectl command. When you go for a declarative approach, using manifest file, we can create the pod. Okay, guys, clear? Now, so whenever we have taken a image name, for this image, it is going to create a container inside the pod. So whenever you use this pod creation using kubectl command, for the given image, container will be created inside the pod. Next one, declarative approach. Declarative approach. Declarative approach means using manifest file. Using manifest file, YML. Using manifest file, we can create a pod, YML file. Okay, so what is that YML file? That YML file will contain key values. YML, already we have seen YMLs in Ansible, right? How to write a YML. In the Docker also, we have seen that, right? So similarly here, we can create a pod by using interactive approach, or we can create the pod by using declarative approach. Creating a pod, nothing but container will be created inside the pod. API version, then we are going to specify kind, then we are going to specify metadata, then we are going to specify spec. So when you are going to create a pod by using declarative approach, that YML file we are going to create. This is the syntax of the YML. API version will be available. What is the kind? What you want to create with this manifest file? What is the purpose of this manifest file? And manifest file data. Data about the data is called metadata. And what is your specification? So what is the image? What is the image you want to use? What is the image you want to use to create this pod? That image details we are going to specify under specification. For this pod, we need to give some names, right? Those names we are going to give a name for a pod. Name we are going to assign by using metadata. Metadata, nothing but data about the data. Kind. Kind represents what is this YML? What is the purpose of this YML? What kind of YML this is? What kind of manifest file that you are creating, that we are going to specify as a kind, and what is the version of your API. API version, kind, metadata, spec. Guys, are you able to understand how to write a manifest file to create a pod using declarative approach? API version, kind, metadata, and spec. API version represents what is the version of your API, like V1, V2, V3, something like that. Kind represents what kind of manifest file it is. What is the purpose of this YML? That will be represented by kind. Metadata represents data about the data. We will give a label, we will give a tag for the pod. This is the name of my pod, like that. Spec represents specification. How you want to create this pod, what container you want to create, what image you want to use to create this. Those things we are going to specify by using this declarative file. API version represents version of our API. Version of our API, like V1, V2, V3, something like this. Kind represents what is the purpose of, this manifest file. What is the purpose of this manifest file? Metadata represents data about the data. Data about data, like labels we are going to give in the metadata. Spec represents specification. What you want to do, what you want to use for this manifest. I want to use some image to create a pod. The image details we are going to specify as a specification. Metadata is used to represent labels. Kind represents what kind of file it is. What is the purpose of this file? Version represents what is the version. If you try today version 1, if you make some changes, then it will consider it as a version 2. If after that, if you make some change, version 3, like this, we are going to use our file, YML file, to create a pod. This YML syntax is very important because in Kubernetes, everything we are going to represent as a YML manifest file. Guys, Are you clear with this? What is pod and why we need to create the pod and how to create the pod? If you want to run your application as a container, you need to create a pod. So if you create a pod, then Kubernetes will schedule that pod for execution. You can create the pods in two ways. One is interactive approach. Second one is a declarative approach. Interactive approach means using kubectl command, right? Declarative approach means manifest file. What is the manifest file? YML. What will be there in the YML? Key value, API version, kind, metadata, spec. Version represents what is the version of this file. Kind represents what is the purpose of this file. Metadata represents labels. Spec represents specification. Are you guys clear? Are you guys clear with this? Come on, guys. Are you guys clear with this? Now, let me create one pod. Let me create one pod. Okay. So here, I want to create a pod for my Docker image, Ashok IT / Java web app. Ashok IT / Java web app, one Docker image is available. For this Docker image, I want to create a pod and I want to execute that in the Kubernetes cluster. Got my point? Okay, let's see how I'm going to create a pod. Good. Here I'm going to use a command vi java web app pod.yml. Okay, so in the Linux, I'm going to use the same command vi editor to create a pod. So what is the first thing that I'm going to use in the pod? API version. I'm going to give it as version 1. API version 1. Kind. What is the first? I'm going to take it as a API version. Then we need kind. Then we need metadata. Then we need spec. These are the 4 keywords common. These 4 keywords are common keys. See here, API version, kind, metadata, spec. It is common. API version. What is the version? First file I'm giving as version 1. What is the purpose of this file? Using this file, what you want to do in the Kubernetes? Using this file, I want to create a pod. Using this file, I want to create a pod. Kind is pod. Okay. Metadata. In the metadata, I'm going to represent a name. So this is Java web app pod. Java web app pod. Okay. And I want to give some labels for this pod. In the Kubernetes, labels are very important. Using the labels only, Kubernetes components will understand all your applications. App. I'm going to specify the app name as a Java web app. API version v1. Kind pod. I want to create a pod by using this YML. Metadata. In the data about the data, what is the name of this? Java web app pod. What is the label? I want to assign one ID for this pod. How to identify this pod in the Kubernetes cluster? To identify this pod in the Kubernetes cluster, I'm giving a label. What is the name of the label? Key value. What is the value? Java web app. I have given label. Now let's come to spec. What do you want to do? I want to create containers. I want to create containers. Let us give some name for the container. So what is this container? Java web app container. Java web app container. So now this is my specification. This is a manifest file for creating a pod. This is the name of the pod. What do you want to do with this pod? I want to create a container. That is my specification. What is the name? Java web app container. So now in order to create this container, we need an image. What is the image? My image available in the Docker Hub. Ashok IT / Java web app. That is my image. Now I want to bind this container to a port, right? Port mapping we have to do. We already discussed in the Docker what is port mapping. Container port, container will be running on the port number 8080. I'm going to map it. Container port. So this is the declarative approach to create one pod for a image. to run the container. So how many ways we can create the pods? We can create the pods in two ways. One is interactive approach. Second one is the declarative approach. Interactive approach means directly we can do like this using command. But in the real time, we are going to use the declarative approach. We are going to write a manifest file to create a pod. My ultimate goal is I want to run my application, my Java application. For Java application, I created a Docker image. The Docker image I want to run in the Kubernetes cluster. Why? If I run my Docker image as a container in the Kubernetes cluster will take care of the deployment, managing, auto scaling, everything. My container will be managed by Kubernetes. Kubernetes is an orchestration platform. I have my image. Image cannot be executed directly in the Kubernetes cluster. If you want to execute your image, you need to create a pod for the image. Kubernetes is going to execute the pod. For your image, a container will be created and will be executed inside a pod. So how to create that pod? By using this manifest file. So you understand what I am writing inside the manifest file? API version, kind. This is a pod manifest file. This is metadata about this pod. And this is the specification of this pod. Specification means what this pod has to do. Specification means what this pod has to do. Metadata means information about the pod. Okay. Kind means it is a pod configuration file, version v1. Are you clear? Are you clear with this one? Come on, guys. Are you guys clear with this one? Good. Guys, name and label both are different. This is the name of a pod. Label I'm giving. In future, we are going to talk about other Kubernetes components like a service, deployment, auto scaling. If one Kubernetes component want to use another Kubernetes component, Kubernetes will use labels. Labels and selectors will be available. Label is nothing but a ID card. One Kubernetes component will understand or will access another Kubernetes component by using label. So we'll come to that. Today only we'll understand what is that label also. Are you clear with my point? Are you able to understand this declarative file? What is API version? What is kind? What is metadata? What is spec? Spec means specification, what you want to do. Metadata means name and ID. Okay. Kind means what kind of file it is. It is a file which is used to create the pod. That's it. Now, once your pod is available, how to create the pod? First, before going to create the pod, check the existing pods in the Kubernetes cluster. Get all pods. To get all the pods, we will use a command called kubectl get pods. If you use kubectl get pods, it is going to display all the pods which are available. Now, here I want to schedule this pod for execution. Are you going to execute the pod, or cluster is going to execute the pod? Are you going to execute the pod, or we will send a request for the Kubernetes cluster to execute our pod? Guys, come on. Now I have my pod ready. I have pod creation configuration file ready. Are we going to execute the pod, or we are going to send a request for the Kubernetes to execute the pod? Come on. We need to send a request for the Kubernetes to execute the pod. Now by using kubectl, I will send a request to the cluster. Who is going to receive our request? When you execute a kubectl command, who is going to receive our request? Control plane API server. Control plane API server will receive the request. Then what the API server will do? API server will schedule that request in the etcd. API server is going to store the data in the etcd. From the etcd, scheduler is going to take the data. It is going to schedule the pod. So scheduler is going to talk to kubelet. Kubelet will tell the availability of the resources. then scheduler is going to schedule the pod execution. The pod will be executed in one of the node which is available here, worker node. Two worker nodes are available. That pod will be executed in one of the worker node. Are you guys getting my point? Create pod using manifest file. Using manifest file. The syntax to create the pod using the manifest file is kubectl apply. Apply is the command. Okay, apply -f use my file. What is my file? Java web application pod.yml. That's it. We are done. I'm going to write this YML. Now I'm going to check what are the pods which are already available in the cluster. Now here I want to execute my pod. What is my pod? Java web application pod. That web application pod configuration available in the YML. Now I want to send a request to Kubernetes cluster to execute my pod. Now how to send a request to Kubernetes cluster to execute our pod? kubectl apply command. I'm telling this is the file. Hey kubectl, use this file. That's it. What is there in this file? Kind pod is available. That means kubectl is going to send a request to the API server. API server is going to schedule. API server is going to store this data in the etcd. Scheduler is going to check in the etcd. Scheduler is going to talk to kubectl and it is going to execute the pod in the node. Are you guys clear? -f representing the file name. Which file it has to use to send a request. -f represents this file name. kubectl apply -f this file name. So this is my configuration file to create a pod. This is the file which is having pod configuration in the declarative approach. Guys, are you getting my point? Are you guys getting my point? What is pod? How to create a pod? How to write the pod configuration file? And how to schedule the pod execution? By using kubectl apply command. Now let's try this. Practically, let's try this. Now, my Kubernetes cluster is running. Guys, yesterday we created the cluster. Yesterday we used Ubuntu 22 version. I already messaged in the Telegram group. Ubuntu 22 version having the issues. Yesterday we got issues several times. Yesterday you have seen we are getting that port issue yesterday, right? So that I have done some analysis. So finally I realized that in the Ubuntu 22X version we are facing that issue. So I created these three machines by using Ubuntu 20 version, 20.04 version in the Mumbai region. Now my cluster setup is ready. One master node available, two worker nodes are available. Quickly, let me connect to them using mobile extrum. Okay, session SSH remote host Ubuntu private key Linux PEM file. Okay, so I connected to my master machine, master node, right? Let me connect to my worker nodes also. Worker node 1, public IP, session SSH remote host, username is Ubuntu, PEM file. Okay, this is my worker node 1. Good. Let me connect to worker node 2. Take its public IP, session SSH remote host, username Ubuntu. Use the private key file Linux PEM. All right, working. Now let me change the tab color for better understanding. Set the tab color, leave it for master as it is. For this, I'm setting the tab color as blue. Node 1. For this, tab color as some yellow. Okay, blue, yellow. Okay, guys. So for master node, I have not done anything. I left it as a blank. So black color tab representing master node, Kubernetes cluster master node. Master node is called as control plane in the Kubernetes. Blue color tab representing my first worker node 1. This yellow color representing worker node 2. Are you clear? Instead of this, we can set the host name also. Later I will tell you how to set the host name. If we set the host name, directly it will display here what is the name of that host. Okay guys, so currently I'm differentiating them with this color combination, or we can rename the tabs also. Anything is fine. Good. Now currently I'm in master node. Let me execute the commands using kubectl. Let me execute the commands using kubectl. Kubectl get to nodes. How many nodes are available? Guys, in my cluster, how many nodes available? Can you tell me? How many nodes available? 3 nodes. What are the 3 nodes available? Can you understand what are the 3 nodes available? All 3 workers, are 1 worker, 2 masters, or 1 master, 2 workers? How can we differentiate them? Master node is having as control plane. Control plane nothing but master node. The remaining 2, this is ready, state ready, and this is also ready. This is worker node. This is also worker node. The middle one is the master node. It is a control plane. For understanding purpose, we can check the IP, private IP. 97 is the worker node 1 IP. See here, 172.31.80.97, 172.31.8.97 private IP. That is 172.31.8.97. This is the private IP of worker node 1. You see here, private IP worker node 1. Now 107, 172.31.14, 107, that is another worker node. See here, worker node 2 private IP 107. This is the private IP of the worker node 2. So in this cluster, we have a master node, we have 2 worker nodes. Are you clear? Now we have all these things. Let me go with get pods command, kubectl get pods, kubectl get pods. So by default, it is pointing to which namespace? Guys, did I specify the namespace? Did I specify the namespace? No, I have not specified the namespace. By default, it is pointing to which namespace now? Default namespace. Okay, Akhil is asking one question. How to join the workers with the master? Yesterday in the installation, I have given the command. Whenever we have done the installation, I have given a command to join the workers with the master. Akhil, you can check that installation document. So using token, we can join workers with the master. So whenever we are doing the cluster setup only, I have done that command execution. The worker nodes already joined with the master. That is the reason when I execute get nodes command, these worker nodes also displaying. Clear guys? Fine. So now with this, we are able to get kubectl get nodes. Nodes we are getting. Kubectl get pods, kubectl get pods, node pods available under default namespace. Are we getting that port issue today? If I execute the commands for multiple times also, are we getting the port issue today? We are not getting the port issue today. Why? Why we are not getting the port issue? That was the Ubuntu issue. Ubuntu version is having some defect. Ubuntu version 22 version having some defect. So that's the reason I have reinstalled my cluster using Ubuntu version 20.04, which is a stable version of the Ubuntu. In that, I'm not getting this issue. Good, fine. Okay, with this, if you check kubectl get pods, currently we are pointing to default namespace. There are no pods available. Pods are not available. Now I want to create a pod. To create the pod, 2 options we have. One is interactive approach. Second one is a declarative approach. Now I want to go with this declarative approach. So I have my YML file ready. Okay. Let's create this YML in any location you can create. See my present working directory. Currently I am in the home directory of the Ubuntu user /home/Ubuntu. Let me create this Java web app pod.yml. File name you can give anything, no problem. Insert mode. Whatever the file I have created, let's take it. Let's keep this. Guys, for clear understanding whether our file is correct or not, can we use that VS Code IDE to check our file is valid or not? Let's go to Visual Studio Code. We already used it to validate our YML files of the Ansible playbooks. So let me go with this file, new file. Let me go for YML. Let me create one YML file here. Yeah, let's keep this. Okay. Now I have taken one file, one thing here in this VS Code IDE. I am keeping my file, whatever the file I have created, API version, kind pod, metadata, Java web app pod, labels web app, spec containers, Java web app container, image ashokite/Java web app. It is available in the Docker Hub. Container port I'm mapping as 8080 ports. So my file seems correct. Syntactically, my file seems correct in the VS Code IDE. Very good. Copy this. Now paste it. Done. Save this file. Good. With this, I have created one YML file. It is called as manifest file. We are following declarative approach to create the pod. Cat. Let me show the content of this file again. Cat Java web app pod.yml. Now, this is the content which is available in this YML. Now, before going to execute the pod, can I show you existing pods? Get pods, default namespace, no pods are available. How to create a pod now? How to create a pod now? kubectl, guys, see very clearly, observe the command which I am using to create a pod. kubectl apply -f my file. That's it. kubectl apply -f Java web app pod.yml. So I am giving this YML file as an input for the apply command. What it will do? It is going to send a request to API server. API server is going to store the data, store the request into etcd. Scheduler is going to take the data from the etcd. Scheduler is going to talk to kubelet. Then it is going to schedule the execution by using controller manager. Good. Now let me do this. Now, can you see pod created message? Did you get a message called pod/Java web app pod got created? So this is the name of our pod. Name is different, label is different. Okay, so my pod got created. Pod Java web app pod got created. What is the meaning of creating a pod? Scheduling for the execution. My container will be scheduled for the execution inside the pod in the node. Now let's check it. Really the pod got created or not? kubectl get pods. Earlier, when I execute this command, I got that no resources found in the default namespace. But now when I execute this command, it is saying that pod is ready, status is running. 32 seconds ago, the pod execution started. It is currently in the running state. Container is running or not? Container is running or not? Come on, guys. What is the meaning of pod scheduling? Pod scheduling is nothing but a container execution. Who is executing this container now? Pod is executing. Who is executing that pod? Cluster is executing. How we send the information to cluster to execute our pod? Apply command. When you execute apply command, what is happening? A request is going to control plane API server. What the API server is doing? API server storing the data into etcd. Who is checking that etcd? Scheduler is going to check the etcd. What that scheduler has done? Scheduler interacted with the kubectl. It verified the node availability. It is scheduled that pod in one of the worker node. How many worker nodes available? Two worker nodes available. Where it is going to execute? Out of those two, in one of the worker node, it is going to execute our pod. Lot of things are happening internally. You look at this diagram. By using kubectl, I executed apply command by using YML file. In the YML, I have a configuration to schedule the pod execution. What I want to do in that pod, I want to run a container. Which container? I have given my image name. Now I executed kubectl apply. That means one request is sent to control plane API server. API server store that data into etcd. Scheduler is going to take the data from the etcd. Then scheduler will schedule the pod execution in one of the worker node by interacting with the kubelet. My God, how much work is doing by Kubernetes? Let's understand. What is the internal process of the Kubernetes? So understanding this architecture is very important. Without having the knowledge on the architecture, you cannot work with the Kubernetes. Samjha? Okay. Now pod is executed. Where the pod is executed now? Where the pod is executed? Pod is executed on the master node. Pod is executed on the worker node. Pod is executed on the master node. Pod is executed on the worker node. We will see that where it is executing. By using commands, we can understand. So how to get all the pods running in the Kubernetes cluster? kubectl get pods. So it is showing that currently your pod is running. The pod is available. Name of the pod is a Java web app pod. One by one, it is running. One pod is running. In one pod is running now. Expected actual. We ask to run only one pod. Yes, that one pod is running. The status of the pod is running status. We are able to get it. Now let's describe this pod. Let's describe this pod. kubectl describe pod. What is the pod name? Java web app pod. When you describe this pod, it is going to show you all the details. kubectl describe pod Java pod. Name of the pod. Namespace is default for this by default namespace. Node. This is the node. Start time, when it started. What is the label of this pod? The annotations of the pod. Status of the pod. IP of the pod. Container, Java web app container. This is a container ID. This is the image which is used to create this pod. Port mapping is 8080. State is running. Started this, ready, true. Environment, mountings, conditions, everything. Can we see complete information of our pod now? Can we see complete information of our pod? By using which command we can see the information of the pod? By using describe command. kubectl describe pod name. Okay, we are able to see the description, the describe. We can describe our pod. So describe the pod by using this command. Describe the pod. Describe the pod using below command. We can, this is called like doing the postmortem of the pod. I am doing a postmortem on the pod to see the internals of that pod. What is the IP address of that pod? Which image is used to create this pod? Which container running in this pod? What is that container ID? When the pod created? What is the status of the pod? Everything I can understand by using describe. Okay, I want to understand where this pod is running. I want to understand where this pod is running. Okay, check where the pod is running. Check where the pod is running. For this, we will use a command called kubectl get pods -o wide. This is the command which is going to display where that pod is running. Go to kubectl get pods -o wide. Clear this. kubectl get pods -o wide. Can you see in which node that pod is running? Can you see in which node that pod is running? What is the node IP? So whenever we execute a pod, for every pod, one IP will be available. When you execute a pod, Kubernetes will assign one IP for every pod, and that pod is running in the particular node 107. Let's see, 107 is the IP of which worker node? Worker node 1 IP is 97. Okay, worker node 2 IP is 107. Can you see? Our pod is executing in worker node 2. See here, worker node. I have a worker node. Can you see the private IP of the worker node? 172.31.14.107. It is running in this. Check the IP, node IP, IP 172.31.14.107. 172.31.14.107. So that pod is scheduled in worker node 2, and pod is having its own IP. Every pod will have its own IP. So this is the name of the pod. This is the status of the pod. This pod started 6 minutes ago, and this is the IP address of the pod. This pod is running in this node. So which command we are using to get the pod information? kubectl get pods-o void. We are getting the information where that pod is running. Now see, I have sent a request to control plane using declarative file. That pod is scheduled by Kubernetes cluster. That pod is executing inside worker node 2. Inside that pod, container is running. My Java web application is running inside a container. That container running inside a pod. That pod is running inside a worker node. Understand my point? Understand my point? Understand my point? Okay. Now let's try to access our pod. Pod is running inside this IP. Inside this IP, this is the pod IP. Port mapping also we have done 8080. Let me do the curl. Actually, I'm executing commands in the which node, guys? Currently, my terminal is pointing to which node? Is it a master node or is it a worker node? Black color terminal, black color tab, master. Blue color is worker node 1. Yellow color, worker node 2. Go to master. Let me do the curl. Curl 192.168.1.129:8080. I'm just sending a request. Am I able to get the response? Am I able to get the response? Am I able to access that container which is running inside this pod by using just curl command? By using curl command, am I able to get that response, guys? Come on. So am I able to access a pod using pod IP from the master node? Actually, where the pod is running? Pod is running in the worker node. But from where I am accessing that? I'm accessing that in the master node. Let me go to worker node 1. Let's hit it. Am I able to access that in the worker node 1 also? Am I able to access that within worker node 2 also? Am I able to send a request to that URL using curl command? Pod is accessible across the cluster. Across the cluster. Now my cluster is having 3 nodes. My cluster is having 3 nodes. Pod is scheduled. Pod is executing in the worker node 2. That pod having its own IP. For every pod, one IP will be assigned. By default, one IP will be assigned for every pod. Using that pod IP, we can access the containers. Using that pod IP, we can access the container. Across the cluster, you can access that pod. From the master node, I have executed curl command. I'm getting the response. From the worker node 1, I'm executing the curl command. I'm getting the response. From the worker node 2, I'm executing curl command. I'm getting the response. So we can access the pod across the cluster using pod IP. Using pod IP. So what is the command? Curl pod IP colon 8080. You can access it from the master node. You can access it from the worker node also. Are you clear with this process? How to create a pod, how to schedule the pod, how to create a pod, and how to schedule the pod? Come on, guys. Now, we cannot access this pod from outside directly. Now, let's see here. Pod is executing. Pod is having a IP. Pod is having its own IP. Pod is having its own IP. Let me check this pod IP. How to get the pod IP? kubectl get pods 0 -o wide. Okay, let's take this pod IP. Go to browser. What is the port mapping? 8080. Hit that URL. I'm using pod IP outside of the cluster. I'm using pod IP outside of the cluster. I'm trying to access. Is it accessible? Using pod IP, am I able to access? No. Let's try by using cluster. Take the cluster IP worker node 2 node IP colon 8080. Is it accessible? Is it accessible with pod IP? Is it accessible with node IP? No. Pod is accessible by default within the cluster. Pod is accessible by default within the cluster. Are you guys able to understand? We cannot access this pod IP outside of the cluster by default. Note, we cannot access pod using pod IP outside of the cluster. Outside of the cluster. This is default behavior. This is default behavior. Now my pod is running. My web application is running inside the Kubernetes cluster inside a pod in one of the worker node. Within the cluster, I am able to access the pod by using IP. But is it allowing me to access outside of that cluster? Is it allowing me to access outside of the cluster? No, it is not allowing me. Okay, so we are going to understand how to access it from outside also. Before going to understand how to access this outside, can we understand pod lifecycle first? Can we understand pod lifecycle? How I created the pod, how this pod is executed, what is the lifecycle of the pod? Okay, make a request to API server using manifest file. Make a request to API server using manifest file to create a pod. Okay, that is a YML. I'm using a YML. You can use normal command also. I mean interactive approach, or you can use the declarative approach. Make a request to API server using manifest file to create a pod. Good. API server will save the pod info in etcd. Okay. Whenever you execute the kubectl apply command, then it is going to receive the request. Whatever the request we sent to execute the pod, that data it is going to store in the etcd. Scheduler finds the unscheduled pod information, unscheduled pod info, and schedules that pod for execution in the node. Schedule that pod for execution in node, that is worker node. Kubelet will see that pod execution schedule. Kubelet will see that pod execution schedule and it will fire Docker runtime. It will trigger Docker runtime. It will trigger Docker runtime. Docker runtime will runs that container. Docker runtime will runs that container inside the pod. This is pod lifecycle. This is pod lifecycle. Understood? Understood how the pods are executing? What is a pod? How to create a pod? How to execute a pod? How to access the pod within the cluster? And what is pod lifecycle? What is the pod lifecycle? Are you clear with this? Are you clear with this? Okay, guys. Good. Next one. Here, note, pod is ephemeral. Ephemeral nothing but it is very short-lived object, guys. Ephemeral, I can say. Ephemeral. That means lives for short period of time. Lives for short period of time. Okay, guys. Pod is ephemeral, lives for short period of time. When the pod is recreated, when pod is recreated, IP will change. When pod is recreated, then pod IP will change. Then pod IP will change. It is not recommended to access the pod using pod IP. It is not recommended. It is not recommended to access the pod using pod IP because pod is ephemeral, lives for short period of time. When pod is recreated, then pod IP will change. It is not recommended to access the pod IP pod using pod IP. It is not recommended to access the pod using pod IP. Are you guys able to understand this? Okay, we will use Kubernetes service component to schedule the pods. We will use Kubernetes service component to execute the pods. Understand my point? Pod is ephemeral. That means it is very short-lived object. Pod will live for only short time in the cluster. When the code is modified, then pod should be recreated. If you modify some code, then we need to kill the pod and we need to recreate the pod. When the pod is recreated, pod IP is going to change. So that's why it is not recommended to access the pod by using pod IP. So that is the reason we are going to execute the pods by using Kubernetes service concept. Service is one of the core concept of the Kubernetes. We will use Kubernetes service component to execute the pods. Service makes pod is accessible inside the cluster and outside the cluster also. Okay. Kubernetes service will make pod accessible or discoverable inside the cluster and outside the cluster also. Inside the cluster and outside the cluster also. Got it? When we create a service, we will get one virtual IP. we will get one virtual IP that is called as cluster IP. This cluster IP will be registered in the Kubernetes DNS component. Cluster IP will be registered. Cluster IP will be registered in Kubernetes DNS. Kubernetes DNS, domain name system. Kubernetes will have a domain name system. When we execute a service for the pod execution, so that service will make the pod is accessible outside the network as well as inside the network. So by default, where we are accessing the pod, we can access the pod across the cluster using pod IP. Is it allowing us to access the pod outside the cluster? Are we able to? Every pod is having one IP, but is it allowing us to access the pod outside of the cluster? No, it is not allowing. So if you want to access your pod outside the cluster, then what you need to do? We need to use Kubernetes service component. Here I have given core components of the Kubernetes. In one of the core components of the Kubernetes, can you see there is a service? In the Kubernetes core components, can you see service topic? Yes. What is that service? Service is making our pod accessible or discoverable inside the cluster as well as outside the cluster. Whenever we create a pod by using service, then what is happening? Kubernetes is going to execute that service. For that service, Kubernetes is going to assign one virtual IP. That virtual IP is called as a cluster IP. Cluster IP will be registered in the Kubernetes DNS with its name, with that service name, Understood? Are you clear? Cluster IP, it is going to assign. Okay. Are you guys getting my point? Pod is ephemeral. Ephemeral means it will live for short period of time. When pod is recreated, pod IP will change. When we are going to recreate the pod, when my code is modified, I'm going to recreate that pod. My container should be recreated, right? When my code is modified, my image is going to change. When my image is changed, my container should be recreated. Code change happened. Developer modified some code. When the code is modified, Docker image should be recreated. When the Docker image is recreated, Docker container should be recreated. Where the container is running, container running in the pod, that means the pod should be recreated. When the pod is recreated, IP address is going to change. So that's why, do we need to dependent on pod IPs to access the pods? Are we going to access the application by using pod IPs? Or it is not recommended to access the application by using pod IP? It is not recommended to access the pods using their IP addresses. Why? IP addresses will keep on change for the pods. Pods will be recreated. When the pod is recreated, IP address is going to change. When the pod is recreated, IP address is going to change. So now, how to schedule the pods now? Directly, are we going to schedule the pods? We are going to use a service to schedule the pods. Come on, guys. Come on. We need to use a service to schedule the pod. In Kubernetes, services are divided into 3 types. In the Kubernetes, services are divided into 3 types. Okay, what is a service in the Kubernetes? What is, guys, we are entering into the most important topics in the Kubernetes. We already entered. I'm preparing a beautiful notes. You don't get this much clarity outside on the Kubernetes. We have done a lot of research on the Kubernetes. Okay. In the YouTube also, in the Udemy also, you will not get this much clarity with the practical implementation, live implementation. Everybody will explain theoretically, but here theory plus practicals we are doing. Everything is practical, live. Concentrate. If you don't listen to the class properly, then that is your karma. Nobody can change your fate. If you don't know the Kubernetes, definitely you will be rejected in the interview as a DevOps engineer. 100% guarantee. If you don't know Kubernetes, you will not get selected in the interview, because Kubernetes is damn important in the market now. It is a hot cake in the market, Kubernetes, and it is a difficult also. It is difficult also. See, from last 2 days, completely our terminology is new. Completely new terminology we are using from last 2 to 3 days. You can understand it. I hope you are enjoying this class. Are you understanding? You talk to your friends who are having industry experience on the DevOps. Tell them that, ask them that, what you know in the Kubernetes. Hey, Kubernetes, I don't know. It's very difficult. Kubernetes, I don't know. It is very difficult. I want to learn Kubernetes from last 1 year. I'm trying to understand Kubernetes. I'm not understanding Kubernetes. That is what your friends will tell you. If you ask any of your friend, developers, 99.9% of the developers are not aware of the Kubernetes. But today it is required. Today it is required in the industry for everybody, developers as well as the DevOps engineers. So you no need to believe my words. You just check with your friends who are working in the IT as a Java developer, as a .NET developer, as a DevOps engineer. You check with them how much they know in the Kubernetes. Ask them, and what is the importance of the Kubernetes also you ask them. They will tell you clearly. Then you will concentrate on the class. Right? Good. Now, so we understood what is a pod and how to create a pod, how to access a pod within the cluster, and what is a pod lifecycle, and why it is not recommended to access the pod by using IP. Okay, now what is Kubernetes service? It is one of the core component in the Kubernetes. What is Kubernetes service? Kubernetes service is responsible to make pods are discoverable inside and outside the network. Okay, guys, service is responsible to make our pods discoverable or accessible inside and outside of the cluster. Inside and outside of the cluster. Service will identify the pod using pod label selector. Pod label or selector. Service will identify the pod using pod label or selector. I told you when I am writing a pod, I have given a label for the pod. So now for the pod we have one YML. For the pod I have created one YML. Okay. For this pod I have given a label. Now pod is creating. Now service also will be created. Now I'm going to create a service also. When I create a service, for the service one more YML file will come. For service one more YML file will come for the service manifest. I will write a service manifest here. So this is pod manifest. This is pod manifest. And this is service manifest. This is also one YML. To create a service in the Kubernetes, I will use service manifest. Why I am writing this service manifest? It is used to make the pod accessible or discoverable inside the cluster, outside the cluster. Okay, how I am going to write this service manifest? In the Kubernetes, there are 3 types of services available. One is cluster IP service. Second one is node port service. Third one is load balancer service. There are 3 types of services available in the Kubernetes: cluster IP, node port, load balancer. I will tell what is the difference between these 3 services. First, let me write a cluster IP service. How I am going to write the cluster IP service? Here also 4 things by default: API version, kind, metadata, spec. We already discussed what is API version, what is a kind, what is a metadata, what is a spec. API version v1, kind. What kind of file it is? Service file. Previously, I have given the kind as a pod. This time I am giving the kind as a service. Metadata. What is the name of this service? I am giving the name as a Java Web App SVC. Nothing but service. Okay. What is the spec? What is the spec? Audible now? Guys, is my voice audible now? Is my voice audible? Yeah. So got disconnected. So it's raining here, and from today almost more than 10 times we lost power. 10 times power cut. This rainy weather, due to rainy weather. Okay. Yeah. Let me write this service file once again. Let me write the service file once again. I'm in the middle of that service file. Okay. Yeah. Let me write my service file, guys. Carefully. There will be a link between service manifest and pod manifest. Okay. So first one is API version v1. Okay. Kind. What kind of service? What kind of manifest it is? This is a service manifest. This is a service manifest. Metadata. What is the metadata? Metadata. I want to create metadata. Guys, if voice is breaking, I can't do anything, man. It is because of network. I connected with the mobile data. Today 7 o'clock class also cancelled because of this network problem. A very interesting topic is going on, but let me come to my balcony. Yeah. Is it fine now? Is it fine now? I came out from the room. Okay. Give me 1 second. Guys, now we are trying to write manifest file. API version I have given as a v1. Kind I have given as a service. What is the meaning of kind? Kind means it is a service manifest file. Metadata. What kind of a metadata it is? It is Java Web App SVC. Java Web App SVC. I have given this. Now coming to spec. In the spec, it is a specification. What type of service you want to create? I want to create a cluster IP service. I want to create cluster IP. So in the Kubernetes, services are divided into cluster IP, node port, load balancer. Now I am going for cluster IP. I'm going for cluster IP. So in this cluster IP, I'm going to specify selector, which is very important. Selector is Java app. This selector is used to identify pod. In the pod, there is a label. That label I am configuring as a selector in the service. So there should be the relation between the service and pod. Service is used to make sure pods are accessible inside the cluster and outside the cluster. So Java web app is the label of the pod. That pod label I am giving in the service as a selector. That is the link between the service and the pod. That is the link between the service and the pod selector. Now ports. What is the port mapping inside this specification? I need to specify ports. So what is the port mapping? I can map the port to 80. I can map the port to 80. So port 80 is a container port. And what is the target port? Where you want to map it? Which port you want to map it? Target port I want to map to 8080. Container port is 8080. I'm mapping to the target port. Target port is 8080. I'm mapping to port 80. So like this, we are going to write a service manifest. Like this, we are going to write our service manifest. Are you guys clear with this? How I am writing a service manifest? Pod manifest is available and a service manifest is available. Pod manifest is used to create the pods. So when the pod is created, one IP address will be assigned for the pod. Using that pod IP, we can access the pod only within the cluster. Now, to make sure the pods are accessible inside the cluster and outside the cluster, I'm using a service. Why? Because pods IPs can change in the future. Pod is a ephemeral device, kind of ephemeral, right? That means it can live short time. When the code got modified, image will be modified, container will be recreated, pod will be recreated. So that's why we should not dependent on the pod IP to access. So that's why for the pod creations, I'm going to, for the pods are already created. To expose the pods inside the cluster, outside the cluster, I'm going for service. In the Kubernetes, there is a service concept. So what is the purpose of service? Service is used to expose the pods. How many ways we can expose the pods? 3 ways. One is by using cluster IP. Second one is by using node port. Third one is by using load balancer. Are you clear? Good. Now, pod is already created. Pod is already created. Let me reconnect to this machine. Due to network failure, I lost the connectivity. Control R will reconnect it. Okay. This is my master node. kubectl get to node. Sorry, this is worker node. This is master node, black color one. This is my master node. kubectl get nodes. There are 3 nodes available. One is the control plane and 2 are the worker nodes. kubectl get pods. Currently, one pod is running. From last 39 minutes, that pod is running. Pod status. Pod is running in worker node 2. Okay, now I want to create a service. So let me create a service for that. vi java web app svc.yml. vi java web app svc.yml insert mode. Let me write the manifest. API version, that is v1, right? Then we are going to specify kind. We are going to specify kind. Kind, I am going to specify this as a service. Then I'm going to specify metadata. In the metadata, I'm going to specify the name Java web app svc. Metadata and specified it. Next one, I'm going to specify specification. Spec I'm specifying. Spec type I'm specifying as a cluster IP. Service type. 3 types of services available. I'm going to specify the service type as a cluster IP. What is the selector? What is the selector? What is the label of the pod? Pod label is a web app. That is the selector. Okay. Now inside the selector, I need to specify name of the selector. Selector name is a app, that is Java web app. That is the label. Then I need to do port mapping. Ports. Okay. So here I'm going to specify port as 80. What is the target port? Target port is 8080. Target port is 8080. So this is my service manifest. Let's save it. Yes. Cat Java web app svc.yml. So I got my service manifest file. Once this service manifest file is available, how to execute this service? First of all, let us check what are the services available. What are the services available? kubectl get svc. Currently, what are the services available? Only Kubernetes service is available based on cluster IP. One service is available by default service, that is a Kubernetes service available. The Kubernetes service is what type of service it is? What type of service it is? Kubernetes service is what type of service? By default, one service available in the cluster. What service it is? Cluster IP service. How many types of services we can create in the Kubernetes? Total, how many types of services we can create in the Kubernetes cluster? 3 types of services. What are those 3 types of services? One is a cluster IP service. Second one is a node port service. Third one is a load balancer service. So currently our manifest file is having what type of service, guys? In my manifest, what type of service I have? In the manifest, what type of service I have? I have a cluster IP. Very good. Now I need to schedule this service for execution. So to whom we need to send this request to execute our service? To the API server by using kubectl command. Okay, so first I'm getting kubectl get svc. What all the services available? It is displaying. Only one service is available, Kubernetes. ls-l, you see pod YML available, service YML available. Pod YML available, service YML available. Using pod manifest YML, we already created the pod. But now I want to expose the pod. To expose the pod, I am using Kubernetes service. In the service, I am using cluster IP. So, okay, let's schedule this service for execution. kubectl apply -y file name Java web app svc.yml. See, for executing the pod, I'm using apply command. For executing the service also, I'm using apply command. How this cluster will understand which file is used for pod creation, which file is used for service creation, depends upon kind in the manifest file. Here the kind is pod, here the kind is service. When the manifest file kind is a pod, it will understand that pod should be created. When the manifest file kind is a service, it will understand that service should be created. Are you guys getting my point? Now, how this service manifest file and pod manifest file are linked? How this service will understand which pod it has to expose using cluster IP? Guys, how this service will understand which pod it has to expose using cluster IP? Using selector. What is that selector? Can I say the selector is a label in the pod? Pod label name is using as a selector name. Pod label name using as a selector name or not? Yes. So based on this selector name, it is going to understand that particular pod it has to expose in the cluster, inside the cluster, outside the cluster. But there are services available. Currently, I am using a service type called cluster IP. Okay, let us see what will happen when we do this. Now, see this. I'm executing a command kubectl apply -y service.yml. Execute. Sorry, not -y, it is -f, guys. Sorry, -f. Now execute. Can you see service got created? Can you see my service got created? Now let's execute. Check the services. kubectl get svc. Okay. Earlier there was only one service called Kubernetes service. Now let us see my Java web app service got created. Can you see my Java web app service got created? Come on, guys. Java web app service got created or not? For this Java web application is cluster IP got generated. For the Java web application, cluster IP got generated. Using that cluster IP, you can access your pod now. You can access your service using that cluster IP. Let us see. Curl, let me tell you how to access this pod now. Curl command, I'm using curl command. Curl cluster IP 10.98.187.60. Am I able to access my application? Am I able to access my application by using curl command? Which one I am using now? Which IP I am using now? Which IP I am using now? Cluster IP. Why I am using cluster IP? What is the service I created in the Kubernetes now? My service is based on what? My service is based on cluster IP service. So it is provided one IP address for this service, cluster IP. Using that cluster IP, you can access your service in any machine. Okay, now you see port is available, target port is available. Target port is nothing but it is a container port. My container is running on 8080. Container is a Tomcat server, right? Web application in the run Tomcat server. It is running on the port number 8080. But I mapped that 8080 port to service port called 80 port. Now my application is running in the container. Container port is 8080. That container port is called as a target port. That target port I map to my host port, that is called 80 port. That is a cluster port. Now, so when I created a service for this pod, what happened? This service is exposing this pod using cluster IP. The service is exposing this pod by using cluster IP. Now, using that cluster IP, you can access that pod. Using that cluster IP, you can access that pod. How to understand what is the cluster IP? kubectl get svs, get the service. When you get the service, it is displaying the cluster IP. Take this cluster IP, go to worker node 1, go to worker node 1 or 2. Worker nodes got closed. Let me connect to them once again due to network failure. Let me go to worker node 1. Let me connect it. Public IP. Okay, session SSH, username Ubuntu. Yeah, use a private key file, Linux spam file. Okay, now I connected. Now let's do the curl of cluster IP. No, not this one. Let's go here, copy the cluster IP, paste it. Am I able to access the application in all the nodes of the cluster using cluster IP? So one virtual IP is generated. One virtual IP is generated for our service, but that virtual IP is called as a cluster IP. Using this cluster IP, you can access that application in any of the node available in the cluster. Okay, let's try. Sir, is this accessible outside the cluster? Is this accessible outside the cluster? Let's try this. Am I able to access the service outside the cluster using cluster IP? Am I able to access the cluster outside using the cluster IP? Come on, guys. No. Cluster IP nothing but within the cluster only. Cluster IP nothing but within the cluster only. Are you guys getting my point? Okay. If I want to provide the accessibility for the pod outside of the cluster, you need to go for node port service. Which service we need to use, guys, now? Which service we need to use now? Which service we need to use now? Node port service we have to use. Understand my point? So if you use a service type as a, first of all, Kubernetes service is used to expose the pods. So to expose the pods, Kubernetes provided services. There are three types of services available: cluster IP, node port, load balancer. When you go for a cluster IP, it is providing one virtual IP address for a service. Using that service, we can access the pod within the cluster, but there is no use of that, right, for us. Now we need to access the pod outside of the cluster. If you want to access the pod, I mean service, if you want Kubernetes service, if you want to access outside of the cluster, you need to create a service by using node port. Let me show you how to create that service by using node port. Let me edit the same file. Let me edit my same file. vi java web app service.yml. Now go to insert mode. Here cluster IP is available. Let me go to node port. What is the service type I am using now? What is the service type I am using now? Node port. Save it. Save it. Okay, good. Now let's do service creation. Let's schedule the service again. Yep. kubectl apply -y java web app service.yml. Now service configured. Let's get the services again. kubectl get svc. Okay. Now can you see? Can you see the port now? Java web app service available. What type of service it is? Earlier, can you see the type of the service? Earlier, can you see the type of the service? Earlier, the service type is a cluster IP. So it generated a cluster IP. Within that cluster, you can access that service by using that virtual IP. In any node, you can access. But I changed the service type from the cluster to node port. I changed the service type to node port. When I changed the service type to node port, can you see service type got modified to node port? Can you see that service type got changed to node port now? Is it modified or not? Come on, guys. Modified or not? Yes, it is modified. Whenever it is modified, you see when we go for node port, it assigned one port to by default for our service, guys. That is the beauty here. Actually, in my service configuration, I told that it should map the port to 80. Target port is 8080. Container running on the 8080. That container port should be mapped to service port called 80. If it is a cluster IP, it will use by default. But when you go for the node port, Kubernetes is going to assign one random port number for our service. This is the port number 32465. Now, our service is binded to 32645 port. 32645 port. Who provided that 32645 port? 32645 port provided by node port service. Kubernetes will provided a random port number for our service. Now we can access this application by using cluster IP with that node port. We can access that by using cluster IP with the node port. Are you able to understand? Okay, let's go to cluster IP. Okay, what is the port? 32645. 32645. 32645. Is that port number enabled in the security group? I'm not sure. Let me go to my security group. Let me go to my security group. Kubernetes security group I used for this. Edit. Go to custom TCP. Enable 32645 port. That is the random port number it provided. Save the rule. Go here. 32645. 32645/Java web app is our application name. Java web app is our application name. Why it is not accessible? Let me check it. Node port service I used. The service got created. Node port Java web application. It is having a IP address and it is having a port number 32645. It is a random port which got created. Let me do curl 10.98.187.60:32645. 32645. Three two six four five. Let me go to my pods, kubectl get pods, kubectl get pods. My pod is running Java web app pod, kubectl get pod, get pods -o wide. Okay, it is running now. IP is available 32645. This is port IP, not this one. kubectl get svc 32645. That is correct. So this is the node port. This is the IP colon 32645. It is there. Application container context path name is there Java web app. We should get it. Is the port enabled properly? In the security group. First of all, what security group I used for all these machines? Under security, security group ID, my Kubernetes, edit inbound rules, custom TCP 32645. Is it correct, guys? 32645. That is a random port it assigned. Okay, that's fine. 32645. What I'm missing here? 32645 is the random port which provided for that. With that port, we need to access. With the 8, yeah. Java web app will be our context path name. No. Node port is there, port number is there. Let me describe this service, guys. So kubectl describe service Java web app service. IP address unset, node port 32645, endpoint 8080, Java web app. Let me try with this endpoint once. Ten dot 98.187.60. That is the node port IP we got. Using that node port IP, we should be able to access outside the cluster. 10.98.187.60:80. Yeah, so it is accessible inside the cluster using 10.98.187.60:80. Let me try to access this. Oh my god. Clear kubectl get svc node port IP I got. Cull 10.98.187.60:8. Yes, it is coming here, but outside is not accessible. Okay, 1 second. Let me go with EC2. Let me use the cluster IP. Instances running. Take the master machine IP address, public IP. Yeah. Now colon 32645. Yeah, perfect. Right, guys. Now it is running with the node port IP. So that node IP address we can use to access. So our application name is Java Web App. Java-web-app. Yes, perfect. Now we are able to access our application. So when we use node port IP address, so what is happening here? When we use node port IP address, it is giving one virtual IP for that. It is giving one virtual IP for that, and it is assigning a random port number. It is assigning random port number. So when you go for a cluster IP, this cluster IP we need to use to access within the cluster. Now we are exposing this service to access outside the cluster. To access the service outside the cluster, we are using node port service. So how I am specifying my node port service? If you see cat of Java web app service.yml, I am giving type of the spec as a node port. Type of the spec as a node port. When you go for node port service, what is happening? This kubectl, if you do kubectl get svc, it is scheduled our service with node port. Now, when we use node port, a random port number it is generating for our node port service 32645. And what about the IP address to access? Within the cluster, you can use any IP to access. Now, master node IP, I am taking public IP. I'm going to hit this master node public IP. See here, I'm going here, master node public IP, node port assigned a random port 32645 : my application is Java web app. Sorry, this is the port, this is IP 32645 slash Java slash web slash app. I'm able to access by using master machine IP. Let's go for worker machine IP, worker node 1, public IP, worker node public IP. Instead of master node public IP, I'm giving worker node public IP. I'm able to access this with worker node public IP also. Within the cluster, any node IP you can use and you can access this application outside. So here, pods we created, the pods are running within the cluster. Pod is accessible within the cluster. To expose the pods outside the cluster, we are using service. In Kubernetes, service is used to make our pods discoverable or accessible inside and outside of the cluster. Service will identify the pod using pod label. We have three types of services. We have three types of services. What are those three types of services? One is cluster IP service. Second one is node port service. Third one is load balancer. Third one is load balancer. First I want to create cluster IP service. So how I have done this? Let me go for cat uh, cat Java web app svc.yml. svc.yml. This is my service manifest file. This is my service manifest file. Here we are going to specify cluster IP. When we use a cluster IP, service is accessible within the cluster. How to execute this? To see all the services, we are using a command to see all the services. $kubectl get svc to get all services. How to schedule a service? Schedule a service using manifest. How I am scheduling a service using manifest? kubectl apply -f java web app svc.yml. Once we have scheduled, you can check it all the services by using kubectl get svc. Okay, once we have done the scheduling of a service, we can check it. So now in the node port service, in cluster IP, one virtual IP will be generated, will be assigned for our service. Using that cluster IP, we can access a service within the cluster. If we want to expose the service outside of the cluster, we need to go for node port service. If we want to expose our cluster, if we want to expose our service outside cluster, we need to use node port service. Okay, how to use a node port service? Simple. The spec type I am going to change to node port. Whatever the spec type I have, the spec type I am going to change to node port. Okay guys, node port. When we use node port, Kubernetes will assign random port number for our service. For node port service, Kubernetes will assign random port number. We can access our service outside cluster using any cluster machine public IP with node port. Enable node port in security group. That's it. Sir, I don't want Kubernetes to assign a random port number. Can we set our own port number? Yes, we can also set our own port number. Here, there is one interview question recently they asked, guys, what is the range of the node port in the Kubernetes cluster? What is the range of node port in Kubernetes cluster? This is one of the interview question. The answer for this is Kubernetes is going to assign the node port from 30,000 range to 32,767. In between, it is going to take one port number. That is the range of the node port in the Kubernetes cluster. If we don't set any node port, like this, if you want, you can set the node port. I will set 32,611, something like this. I can set our own node port. If we don't set our own node port, then Kubernetes is going to assign a random node port. When we need to go for cluster IP, when we need to go for node port, when you go for cluster IP, one virtual IP will be generated for a service. Using that virtual IP, we can access the application within the cluster. If you want to expose the application outside the cluster, then we need to go for node port service. How to make our application service as a node port service? Using the spec type as a node port. When we specify the spec type as a node port, we can specify node port. If I comment it, for node port service, Kubernetes will assign a random port number if we don't specify. If we don't specify node port in manifest file. If we don't specify the node port in the manifest file, Kubernetes will assign a random port. What is the range of that node port? 30,000 to 32,667. Within this range, it is going to set that port. Now, we will enable that port in the security group using cluster machine, any one of the cluster machine. It can be a master, it can be a worker. Using the cluster machine IP, EC2 VM public IP, URL to access application. Okay, http://EC2 VM IP : node port / context path. Application context path. What is my application context path? Java-web-app. That is the context path. Java-web-app. This is the context path. So within the Kubernetes, we are able to access our application. We are able to deploy our application using service, node port service. That service is identifying the pod, service is exporting the pod. To run the application, we need to create a pod. Pod is a smallest building block that we can execute in the cluster. Pod manifest we created, service manifest we created. So what is the purpose of the pod? Pod is used to execute our application. What is the purpose of service? Service is used to expose our application. Pod is used to execute our application as a container within the cluster. Service is used to expose that pod outside the cluster by using node port service. Clear for all of you? Guys, I can't stand more time here. Mosquitoes are eating me like anything. I'm standing outside. Okay, so can you guys practice this before coming to tomorrow's session? So tomorrow we'll talk about new concepts in the Kubernetes. Today we are done with what is pod, how to create a pod, what is pod lifecycle, how to access the pod, and what is service, why we need to go for service, how many types of services available, how to create a cluster IP service, and how to create a node port service. Guys, a lot of depth is there in these concepts and very important. Okay, so next we are going to talk about the load balancer service and the remaining services available in the Kubernetes. Okay, I will update this class notes, guys. So please practice before coming to tomorrow's session. Bye-bye. Good night. Thank you, guys. Thanks you for your wishes. Happy Guru Purnima. Thank you so much. Thank you. Good night. Please practice before coming to tomorrow. If you don't practice, you can't understand anything. Please practice it.